Hello learners, welcome to the session on packaging techniques and machines used for food. This is a part of the MOOC on food fundamentals and chemistry. In the previous session, you learnt about the importance of food packaging, the types of packaging materials, the forms of packaging which are used for different types of food. So you know that the packaging requirements of different food groups, even within the same food group for different products, for dried products, frozen products, for cured or canned products, the packaging requirements are different. So accordingly, various packaging techniques have been evolved over the years according to the need of the food industry, according to the package requirement of different food groups, and also as per the convenience of the consumers. So in this session, you will learn to explain various modern packaging concepts, outline the salient features of various packaging techniques like vacuum packaging, modified atmosphere packaging, aseptic packaging, retort packaging, active packaging, and intelligent packaging. We will also be able to describe two eco-friendly packaging, that is edible packaging and biodegradable packaging. And lastly, you will learn to enlist the packaging machines which are used in the food industry. So let's begin with the packaging techniques. So the simplest method we know, that is about the aerobic packaging, where the food is packed in a bag or any other container with air without adding anything to the packaging material or to the packaging environment. So that doesn't provide the long shelf life for the highly perishable product. So what we can do, we can adopt different packaging method like vacuum packaging. So what is vacuum packaging? So from the name itself, you can have that idea that the vacuum is created inside the packaging environment, inside the package. That means all the air is removed from the package just to control the oxidation and the microbial growth. You know, if there is oxygen in the package, that will lead to the oxidation of the product. That will also help to grow the aerobic microbes in the product. So that can be prevented by vacuum packaging. So by vacuum packaging, we can extend the shelf life of the product. For example, the shelf life of the cheese is normally 1 to 2 weeks, but if we go for vacuum packaging, we can keep the cheese for 4 to 8 months. Even we can keep the nuts for 2 years in vacuum packed. So vacuum packaging also prevents the loss of moisture at the product surface. And as the air is removed, the volume of the package will be less, so it will require minimum storage space. And this vacuum packaging can be used for various products like fruits, vegetables, frozen food, pizza, seafood, meat, etc. And the types of packaging material we need for vacuum packaging, that must have very good property, barrier property, especially against the transmission of the gas. So we can use different types of laminates or co-extruded film. Laminates can be made of plastic with aluminum foil, nylon or EVA laminates, PVDC, polyester, polyethylene laminate, etc. So another type of packaging is the modified atmosphere packaging. That is even better than the vacuum packaging. So what is meant by the modified atmosphere? That means the package environment, the environment inside the package is modified with help of some gas to prevent the microbial growth, to prevent oxidation and the autolysis. So the air can be removed and that can be replaced with various gases like the carbon dioxide, the nitrogen or the oxygen as per the requirement of the product. And modified atmosphere packaging can be of two types. One is passive, another one is active. Passive normally happens with the fruits and vegetables. When we pack fruits and fresh fruits and vegetables in the package, even after harvesting, even after packaging also, the fresh fruits and vegetables that respires, that consume oxygen and produce carbon dioxide. That's how they can change the package environment. So that is the passive modified atmosphere packaging. And if you see the active modified atmosphere packaging, where we deliberately remove the air and we add some different gas, maybe carbon dioxide, nitrogen or oxygen. So modified atmosphere packaging helps to extend the shelf life of the product. It also maintains the high quality product, fresh appearance of the product, and it is very user friendly. We can use the modified atmosphere packaging for meat, fish, poultry, fruits and vegetables, snacks, baked products, ready to meal, etc. So here in the table you can see the different gas composition which can be used for the different food groups. First, you can see the composition for the packing of oily fish. You know, oily fish has very high level of fat content. So fat is prone to oxidation. We can prevent that oxidation by the absence of oxygen. So we can use only the carbon dioxide 40 to 60%, nitrogen 40 to 60%. You know that nitrogen is an inert gas that doesn't react with the product. So, but there is also exception like the red meat. Fresh red meat needs to maintain its bright red color. That depends on the oxygenated state of the meat pigment, that is myoglobin. So, we need the oxygen in the package to maintain the bright color of the red meat. So, there we can use 15 to 30% of carbon dioxide and 70 to 85% of oxygen. Again, in case of fruits, if we take the example of apple, that needs little bit of oxygen. We know that for respiration, the fruits and vegetables need oxygen. So, if there is high level of respiration, the aging of the product will be very fast. So, product will spoil very fast. So, we need to restrict that aging of the product. So, we need to reduce the level of the oxygen. At the same time, if we remove all the oxygen, that will lead to anaerobic respiration, which will ultimately form different ethanols, alcohol, acetaldehyde, so which will lead to the off flavor of the fresh fruits. So, what we can do, we can use 3 to 8% of carbon dioxide and 2 to 5% of oxygen. That will keep the balance between the aerobic respiration and anaerobic respiration, and rest of the amount can be used as a nitrogen gas. For non-respiring product like cheese, that also has high quantity of moisture and fat. So, we can remove the oxygen to prevent the oxidation. We can use the 0 to 70% of carbon dioxide and 30 to 100% of nitrogen. So, we can use here 100% of carbon dioxide, but what will happen if we use 100% of carbon dioxide? That is also dissolved in the water or the fat phase of the product. So, there will be negative pressure in the package and there will be a chance of collapse of the package. That is why we should use some quantity of carbon dioxide along with nitrogen gas. For products like potato chips or coffee, there is no need of oxygen, there is no need of carbon dioxide also. So, we can use 100% nitrogen. For potato chips, you might have noticed the pillow packs, which are puffy packs. That nitrogen filling also helps to provide the cushion to the products, chips, because chips are fragile. So, we can give the cushioning effect of the product through this modified atmosphere packaging. Now, we will see the aseptic packaging. So, for aseptic packaging, you know that there are requirements 3 sterilized things. One, we need the sterilized product. Second one, the sterilized packaging material, and we need to pack that sterilized product in the sterilized packaging material under a sterile environment. So, we have to ensure these 3 things. So, how can we sterilize the packaging materials, the packaging equipment and the filler environment? That can be done through the chemical sterilization with ethylene oxide, sodium hypochlorite or the hydrogen peroxide. Normally commercially hydrogen peroxide is used, and then you can also use the physical sterilization process like with hot air or steam, and also go for UV radiation. So, we have to also remember that the package seal should have that integrity through hermetic seal. That means it should prevent any kind of recontamination after the packaging and processing. This aseptic packaging can be used for milk, cream, other dairy products, then juice, pulp, tomato puree, ketchup, soup, ready to drink tea or coffee, and this aseptic packaging helps to extend the shelf life of the product, and the products are shelf stable. That means you can keep the product at room temperature unless you open that container. Okay, so it can also give the better product quality and consumer convenience, but there is disadvantage also because it involves high cost and it is not suitable for all type of food products. So, here you can see that the packaging material which is used for the aseptic packaging, this is an example of a Tetra Pak. The packaging materials normally uses different layers. Here you can see the 6 different layers. So, outermost layer is made of polyethylene, which gives the protects the product from the moisture. The second layer is the paper board, which gives the mechanical strength to the product. Its packaging material. Then next layer is the polythene, which acts as binding or adhesive layer. Then comes the aluminum foil layer, which prevents the transmission of oxygen or flavor or light. Then next layer is the polyethylene that again acts as adhesive layer, and the final layer is also polyethylene which seals in the liquid. So these are the layers of the aseptic packaging. So aseptic packaging container can be prefabricated or can be formed during the filling and sealing of the product. So that is known as form, fill and seal. So it can be in the form of cartons, cups, Tetra Pak, Tetra Break, pouch, bottle, etc. Now we will see what is retort packaging. You must have read about the retort processing of food. So you know what is retorting. This is the high heat processing under high pressure in a retort vessel to make the product commercially sterile. So what is meant by commercially sterile? That means when we make the product free from any kind of live microorganisms which is of public health importance, and any kind of spore forming microbes or toxin producing microbes, especially for example Clostridium botulinum. So then we can say that this is commercially sterile product. So temperature requirement for retort packaging varies from the product to product depending on its pH or the water activity level. For example, for low acid food like meat or fish, the temperature should be high. It should be around 120 degrees centigrade to 130 degrees centigrade, and pressure also should be very high, like 15 pound pressure for certain period of time, certain holding period of time, just to make the product commercially sterile. Or packaging material you can use as the traditional cans, the jars or the retort pouches. So the retort pouches which should be made of laminates or co-extruded film just to provide the strength, the barrier to oxygen, moisture, and toughness, and puncture and burst resistance, and it should also withstand the high temperature processing. And retort pouches, laminates or co-extruded film can be made of PET, aluminium foil, nylon, HDPE laminates, etc. And it provides the product the shelf stability. We can keep the product at the room temperature. It extends the shelf life very high from few weeks to few years. For example, you can keep the retort pouch product for 1 to 2 years, and it also provides good product quality. So you can use this retort packaging, retort pouches for meat, fish, milk, ready to eat meal, processed fruits and vegetables, etc. Now we will see the active packaging system. So this packaging performs a role other than an inert barrier to external environment. So active packaging changes the condition of the packed food to extend the shelf life or to improve the safety or sensory properties while maintaining the quality of the packaged food. And the food condition it changes are conditions like the physiological process like respiration of fresh fruits, or chemical process like lipid oxidations, physical process like the dehydration of the product, or the microbial growth or spoilage of the product. So these can be changed by application of active packaging system. So subsidiary constituent is deliberately included in or on either the packaging material or packaging headspace to enhance the performance of the package. And these can be used in the form of sachets, films, cork, labels, etc. There are 3 different types of active packaging systems, mainly 2 different types, absorbing type and releasing type. Then another category is miscellaneous, which examples are like the self-heating or self-cooling containers. So now we will see what are the different types of absorbing active packaging systems we can use for different types of food. First one is oxygen scavenger. We know if we want to remove the oxygen from the package, we can use the oxygen absorbing or the scavenging some chemicals or product like iron based product, ascorbic or metallic salts or enzyme based products in the form of sachets, labels, films, corks, etc. So this will reduce the microbial growth and prevent the oxidation of fat, oil, vitamins and color. So this packaging can be used for the bread, cake, biscuit, cheese, cured meat, fish, coffee, etc. Next comes the carbon dioxide scavengers. So if you don't need the carbon dioxide to store in the package environment and which may lead to the bursting of the package, then we can remove the carbon dioxide by use of scavengers like the sodium hydroxide, calcium hydroxide or calcium oxide, or the activated charcoal in the form of the sachets in the package. We can use this for coffee, meat, snack food, etc. Then ethylene scavenger. You know ethylene is the plant hormone which actually leads to early ripening of the product. If you want to prevent the ripening and the softening of the fresh fruits or vegetables, then you can use the ethylene scavenger in the food package. So what are the scavengers like the potassium permanganate, activated carbon, silica gel, zeolite, etc. that can be used for the fruits and vegetables. Then moisture regulator. You must have seen that there is a small pouch of silica gel inside the package of electronic gadgets. So that absorb the moisture. So that can regulate the moisture inside the package. The same principle can be used for the food products also. Silica gel, activated carbon, calcium oxide, natural clay in the form of sachets we can keep inside the package that will absorb the moisture. So we can use it for meat, milk powder, coffee, cheese, chips, popcorns, candies, etc. Another type of absorbing active packaging system is UV light absorber. You know, UV light actually helps to oxidize the product. So just to prevent the oxidation, so we can use UV light stabilizer in the plastic bottles or films for the light sensitive food group like cured product like ham, bacon or different drinks. We can also use lactose remover for the milk and milk products. You know that there are few people who are actually suffering from lactose intolerance. So for them, we can prepare the milk without lactose by using the immobilized lactase enzyme in the packaging material. So all these are not very commercially popular, but the oxygen scavenger, carbon dioxide scavenger, ethylene scavenger or moisture regulators are popularly used in the food industry. Now we will see the second category of active packaging system, that is releasing active packaging system. Here the packaging system will release or emit some kind of desirable product. For example, carbon dioxide emitters. We know that carbon dioxide can prevent the fungal growth in the product or some of the microbes, microbial growth. So we can use carbon dioxide emitters in the form of sachets, and we can use the chemicals like ascorbates, sodium bicarbonate or ferrous carbonate for the products like fresh meats, fish, cheese, vegetables, etc. We can similarly use sulfur dioxide emitters for extending the shelf life of the product. We can use the chemical sodium metabisulfite in the form of the sachets for fruits. We can also use antioxidant releasers. You know that there is a chance of oxidation of the fats and oils present in the food. Just to prevent that, we can add antioxidant releasers to the package, which can be used in the form of films. So we can add the BHA or BHT or tocopherol for the product like dried and fat containing food. We can also add some desirable flavors to the product through its packaging material or packaging environment. So we can use the flavoring emitters and flavors in polymers for the miscellaneous food. Another important releasing active packaging system where we can use the antimicrobial. So you know, for preventing the growth of the microbes in the food or preventing the spoilage or microbial spoilage of the food, we can use some antimicrobials. Antimicrobials can be the ethanols and other alcohols, the organic acids like benzoic acid, sorbic acid, propionic acid, fungicide, enzymes like lysozymes, spice, herbs, extract, and bacteriocins like lysine or periosins. We can use all these antimicrobial releasers in the package itself, or we can add to the packaging material. So we can use that antimicrobial releasers for different types of food like meat, fish, cheese, bread, fruits and vegetables, etc. I also mentioned a third category of active packaging system, that is miscellaneous active packaging system, where I gave the example of self-heating container. So there is a demand from the consumers that they need the product ready to eat or ready to drink product in the form of self-heating containers. So there the lime and the water mixture is used. When these two react, that will produce the heat and that will keep the product in hot condition. So that can be used. Similarly, there is also demand for self-cooling container for the cold food or drinks. So there you can use the mixture of ammonium chloride, ammonium nitrate and water to keep the product cool. So these are the examples of the different types of absorbing, releasing and miscellaneous types of active packaging system. Now we will see very important packaging system, that is smart packaging or intelligent packaging. What happens here? So this intelligent packaging, it monitors the condition of the packaged food to give information about the quality of the packaged food during transport and storage, and it contains the external data carriers or external or internal indicators or sensors to provide the information about package history and or the food quality. Broadly, this can be of two types. One is data carriers. I hope you all have seen the barcodes or QR codes or RFID tag on the package as a label. So what does it do? It actually helps to flow the information within the food supply chain. For example, the barcode can give us the idea about the lot number, batch number, manufacturer's details, the expiry dates, etc., or the price of the products, etc. And the QR code can also help the consumer to get the instructions for the storage or cooking of the product. So all this information we can get from these data carriers. Second category of intelligent packaging is the package indicators or sensors. This is very important because this can give us the idea about the quality of the product during the storage and transport. By seeing the label on the package, the change in the color of the label on the package, the consumers can have that idea whether that food is still fresh, we can have it, or we should throw it, it has already spoiled. So this actually depends on the various principles based on the chemical changes that takes place on the package, that the mechanical changes or the enzymatic or the immunochemical or the biological changes. All these can be identified by the change of the color on the package label. So these can be quality or freshness indicators or biosensors, can be time temperature indicator, can be gas concentration indicators, can be microbial growth or pathogen indicators. For example, time temperature indicator. For example, if we take the example of the storage and transport of the chilled milk or the frozen product in the refrigerated van. So what happens? There may be a temperature fluctuation during the transport or the storage, and that can be detected through these indicators, the time temperature indicators, through some chemical changes or through some mechanical changes or enzymatic changes. So there will be color change on the label. In the photo you can see this is the freshness indicator. So the topmost photo you can see there is a light shown in the center and outer ring is blue in color. So if that indicates the freshness of the product, it is written like fresh. So consumer knows that if color shows like this is ready to eat. In the center position you can see the color is same for the ring and the center position, all are blue. So it indicates that it is still fresh, but it should be used now immediately. And the third and the bottom picture you can see that the outer ring is lighter in color, central position it is darker in color. So it indicates freshness not guaranteed. So we should doubt the quality of the product and we should throw it, we should not consume it. So this way, these indicators or sensors can communicate with the consumers about the product quality during storage and transportation. So this is the advantage of the smart or intelligent packaging. Now I will discuss about two eco-friendly packaging, those are edible packaging and biodegradable packaging. So why do we need this type of eco-friendly products? So nowadays you know we have so many different types of packaging materials, especially the packaging materials. Plastic packaging materials helps us many ways, but it also creates nuisance. It also leading to the environmental pollution. These are not biodegradable. So these will remain in the environment for a long time. These are not compostable. So for that we need to have some kind of solutions in the form of packaging which are biodegradable. So for example, edible packaging. Edible packaging, that means we can consume that packaging material and we don't need to remove it before consumption. For example, if you have seen the packaging of the meat product, that is sausage, which can be packaged in the plastic packaging, it can also be packaged in animal casing. Animal casing we can consume along with the sausage, there is no need of disposal. So that is an example of edible packaging. Again, if you have seen that there is a wax coating on the apple, so we can consume that coating also along with apple if we are using edible type of wax, for example bee wax if we are using, so that can be eaten. So these are edible packaging, these are eco-friendly, no disposal problem, these are produced from the renewable edible ingredient, and these can also provide nutritional value to the product, sensory qualities, color and flavor to the product. We can also add some antimicrobial agents, antioxidants or preservatives to the edible packaging material, and these packaging material can be used as the films in the form of films or coatings. And the materials that can be used for preparation of edible packaging are like the lipids, proteins or polysaccharides. Lipids, for example, you can use bee wax. For protein, we can get the protein gluten from wheat, zein from corn, casein from milk, gelatin from animal source. We can use the starch, cellulose or pectin as a polysaccharide sources for making this kind of edible packaging. Now we will see what are the biodegradable packaging. That means these can be degraded by the microbes and these will not threat the environment anymore. So we need to produce biodegradable packaging by using some biopolymers or bioplastics. These are eco-friendly This can be either produced chemically or microbially, and this can be used as a film, coatings, wrap, bottle, disposable service items, etc. So here you can see the examples of some of the synthetic biopolymers like polylactic acid, polymalic acid, polyhydroxyl alkanoate, and you can also make some biodegradable plastic packaging from the protein sources like collagen, gluten, soy protein, zein, casein, whey protein, etc. You can also use the carbohydrate sources like the pectin, starch, cellulose, chitin, ketosane, etc. So all these will lead to the biodegradable packaging, and these are eco-friendly. These can be used for various types of food products. So I discussed till now about the different packaging techniques. Now I will tell you about the packaging machines. You know, packaging machines are very important because they ensure that packaging can be done at high speed and high energy efficiency with minimal breakdown. So there will be less chance of waste of packaging materials, less chance of waste of the food materials. So we need the efficient packaging machines. Normally we need packaging machines for two different purposes. One is the filling of the product and the other one is the sealing of the package. So we need the container or bag filling and sealing machines. Then filling can be done in the preformed container or filling a container with contents after container is formed from a roll stock. So that means while we are filling the product, we are forming the package first, then we are filling and sealing at the same time. So that is the form, fill and seal machine we need. So form, fill and seal machine can be vertical type or horizontal type, and by using this machine we can prepare different types of packaging like the pillow type bag, stand up pouch, twist seal bag, square bottom bag, thermoforming tray, etc. Then we also need some machines for tying and packing. We can also have some machines for lined folding carton packing, and we may need some wrapping machines for packaging, for primary packaging, for secondary packaging. These wrapping machines can be folding type, over wrapping, twist type wrapping, stretch film, shrink film. And lastly, we also need some machines which will help us for the labeling, marking and product identifications. In this slide you can see the photo of some of the packaging machines like vacuum packing machine, you know, where the vacuum is created and the package is sealed at the same time. So this is vacuum packaging machine with some modifications, with additions of the flushing of the gases. We can have modified atmosphere packaging machine. Then you can see the bottling machine where the bottles are filled and capped. Then the form, fill and seal machine. Here you can see the vertical type form, fill and seal machine. The topmost level you can see the roll stock which will form the package, and at the same time the product will be filled and sealed. And next you can see the thermoform, fill and seal machine where the thermoform trays or webs are formed, at the same time it is filled and sealed. So then you can see shrink packaging machines where the primary package is wrapped with the shrink film, and then you can see different types of sealing machine, heat sealing machines. First you can see which is used for the sealing of the plastic packages. Then you can see the tray sealing machine which is used for the sealing of the trays. Then you can see the canning machine, that is for the retort packaging. Cans or retort pouches can be packed in the retort packaging system. So these are all about the packaging techniques and the packaging machines. Now it is a time for summarizing what we learned today. So first we learned the working principle, the advantages, disadvantages and applications of vacuum and modified atmosphere packaging. Then we learned how aseptic packaging and retort packaging extend the shelf life of the product and provide consumer convenience. Then we learned salient features of various active packaging, whether absorbing or releasing or miscellaneous types. Then we discussed how intelligent packaging provides information about the product history or monitor the product quality during transport and storage. Then we saw the advantages, applications and materials for edible and biodegradable packaging which are eco-friendly. And lastly, we also came across some of the packaging machines which are used for the filling, sealing, wrapping, etc. in the food industry. So this is all for this session. I hope you learnt about the basics of the packaging techniques and the machines which are used in the food industry, and I hope that you will be able to answer the questions which will be shared with you at the end of the session. Thank you for watching this video. I wish you happy learning.